Meet Tom, and like you, he loves pizza. Tom's mum says that he and his brother can each have a slice of pizza. Both boys want the larger slice. One slice is 5/5 of a pizza, and the other slice is 5/8. Tom has the first choice. Which slice should he choose to get the biggest slice? Comparing two fractions with different denominators can be tricky. Benchmarking is a strategy that we can add to our mathematics toolbox to help us solve questions like this. When we compare the value of two unfamiliar fractions, we can use our knowledge about what a half and a whole is to estimate what a fraction might mean. This can be done by estimating that a fraction is close to 0, a half, or a whole. Let's look at the fraction 4/5 as our example. When we look at this fraction on the number line, we can see that 4/5 is larger than a half, and almost a whole. So we could say that it is close to a whole. Let's use this thinking to answer the question at hand. Let's take a look at a number line. As we noted earlier, 4/5 is almost a whole. And if we have a look at the fraction 5/8, we can see that it's just a little bit more than a half, so we could say it is close to a half. So to answer the question which slice is larger, we now know that 4/5 is close to a whole and 5/8 is close to a half. Therefore, we know that 4/5 is the larger piece of pizza. Let's have a look at this another way. Using what we know about equivalent fractions, we know that 4/8 is equivalent to 1/2. Therefore, 5/8 will be just a little bit more than a half. If we were to compare this to the fraction that is 4/5, we know that 4/5 is much more than a half, but a little bit less than a whole. It would look a little bit like this. So as we can see, 4/5 of a pizza is much larger than 5/8. What if Tom's mum made it a little trickier and said one slice was 4/5 of a pizza and another slice was 5/6? Both fractions are close to a half. How do we work out which is larger? To help us, we can use a new strategy called residual thinking. Residual thinking requires us to ask ourselves a question: how much more do I need to make this fraction a whole? Looking at the two fractions 4/5 and 5/6, we know that each fraction requires one more part to make each a whole.